okay? Uh, I don't know if it. Yeah, it should be on.
Yeah, but
It's all good. Yeah, yeah.
check one, check one,
Yeah. Soon.
check one. Check. Does it work or not? It works. Yeah? Alright. Oh, okay. Alright. Yeah, sure. Alright guys, all welcome. A couple of new faces today. Low attendance because obviously we've actually got a bit of sunshine, so people are probably down the pub drinking beer. Yeah, as well. Exactly. Yeah. Sorry, I need to hold it closer to my mouth. Yeah, so welcome. We're ECS Digital. For those of you that don't know, we're one of the UK's leading digital and Devops transformation consultancies. And we do this on a regular basis. So once a month, we get one of our consultants to pick a tool and to go through it with you guys, get your laptops out, and to learn something new. So I don't want to take up too much of your time, so I'll let Vlad start. Okay? I'm not sure.
Yeah. So, hi guys. Thank you for coming. So first things first. Have that link. That link will have essentially a guide through with everything that you need to set up videos of what we'll be talking. All the resources are there. So, a few words about myself. I'm a QA continuous delivery consultant. I've been working as a QA lead and on different QA projects for about 8 years now, mostly doing automation with Java and essentially the whole ecosystem of Java, which JMeter is part of. Should we get cracking? Oh, okay, I'll wait. So during the talk, if you have any questions or anything, just speak up and we'll stop and discuss.
Do we need to be inside?
So not for now. For now, it's okay. But at the end of the talk, we'll have a workshop. If you want, there are machines that are prepared so we can do an exercise together. What we'll be doing is a web crawler. I don't know if it's familiar to any of you, but essentially you'll find it in a lot of tools on tools that essentially investigate websites or stuff. So this is just a way for us to kind of understand how that works, right? Okay, so a bit about the content. So we'll go through how do we choose the right tool. I think it's important to understand always what we're trying to achieve and to choose the right tool for the job. Concepts and terminology. So these talks, we assume that the people don't need any prior knowledge. So because of this, we're going to go through some of the concepts that are needed, to kind of understand and kind of go through this. Then we're going to look at some JMeter components that we'll be using, and at the end, we'll do a small workshop. That's all. Good. Okay, so how do we pick the right tool? Does anybody do performance testing or? Okay, good. So this might help you a bit. So when you're thinking about performance testing tools or tools in general, you kind of have to understand a couple of things. First things first is the team and your people, what kind of skills they have, right? So you shouldn't try to find the tool that is, best ranked on Google, but you can't use it, right? There's no benefit in that. So that I would consider that to be the first thing, right? Then what kind of testing do you need to perform, right? What kind of system is under test? What is it, a streaming system? What type of system is it? And what kind of load, or what kind of testing you need to generate? Because it might be that you don't need to generate a large load, you just need to generate a consistent load and something that's comparable. Or you might need to use a really high throughput tool that you might need tests might be a bit more difficult to implement, but you get the benefit of that high throughput and, you know. So then it's infrastructure constraints. Now, in some cases, some of your clients might say, okay, we can only run Windows machines. So then it really limits the number of tools that you can use, right? Or you have considerations like funky logins. When I say funky login there, I'm thinking of single authentication systems. Now, if you're starting to hit a system like that with a load, the IT support might come on your head, right? So you have to understand these kind of things, right? So, in order to kind of understand, you know, the complexity, what I usually do, I look at mind maps, right? It gives me a bit of clarity of things that I didn't look at, you know? So, if you think about, if we're looking here, so system monitoring, if you need something like server-side monitoring, you know, things that didn't come in your mind, what kind of benchmarking we need to do, what kind of test approach, you know, maybe we need to do some isolation testing on some components, but maybe we need to do system-wide testing, right? So there's different aspects in that. So essentially, you can take a mind map like this and essentially go and ask your stakeholders, you know, find as many of these answers, answer as many of these questions as you can. So that will give you the first phase of your analysis, right? So once you kind of understand what are your requirements, what you're trying to do, you're going to go on the web and start searching for tools, right? Yeah, keep in mind on most of the slides you'll have a source. Essentially, it's either the source or a link to the documentation that's relevant for the slide. So what we're seeing here is essentially the top tools considered by JMeter in terms of features comparison, right? So what we're seeing here, we have 3 JVM based. So you have Grindr, Gatling, and JMeter that are JVM based. But there's quite a difference. You have Python enclosure with Grindr, and you have Scala with Gatling. And yeah, protocols it's another important feature. You really need to match the protocols that you're trying to test with the tool's capability. And yeah, you might need stuff like host monitoring, right? So you might need like a client on the server to get metrics from the server load and stuff like that. So not all tools provide that, right? So you have to kind of understand. Now, for us, we chose JMeter because of that yes. So it's the only tool that has a GUI, right? So it's easier to learn for us. Do you have any questions on this or anything?
Is it just GUI based or script?
You can script. So there's a trick there, and we'll have a look. So JMeter supports pre-scripts and post-scripts for that request, right? And you can essentially write the scripts in JavaScript, Groovy. You'll have a lot of languages. So actually, it does mention a couple of them for the extensions, but yeah. Yeah, go for it. All good? Okay, so once you kind of decided on your tool and you understand your environment, then you have to dig deeper into your server topology. Which are the components that you're trying to test, right? What kind of setups you need to do, right? Maybe you have to do some data preparation before you're running your suit, right? And then you might need to do some cleanup. So yeah, also keep in mind, not all tools are very well documented. It's really important to kind of, you know, find all the relevant resources when you're using a tool. And why I'm saying this is, in some cases, you might be the canary down the line. And it's really nasty to deliver a product, you know, a production-ready product, and you're essentially testing the product. I wouldn't recommend, you know, use like immature products for production-ready stuff. So it's not only features, right? With tools, it's also we're interested in throughput, because this is essentially what we're trying to do, right? To generate a certain load. Now, if you're doing, like I said, if you're doing something really low latency, high intensive, you might want to go with Locust because it performs better than JMeter. But if we're looking in the JVM-based tools, JMeter is actually performing quite well, right? The source. Okay, so this mind map is more related on how you essentially prepare your tests. This looks more into test data, how you prepare your sets of data, how you design your tests. You have to think about your data state, right? You might need to bring all that data in a certain state to have the system testable. So if you'll go through some of the issues raised here, you'll see it goes across from networking to setting up your script, to where you're running it, to how you set up the infrastructure, because other problems might arise, right? Like, for example, if you're trying to generate a load for 5,000 people, right? You might not be able to do it off of one machine, right? So you might need to scale out of that. So I would use something like a mind map just to explore and dig deeper into the problem. I usually focus on 3 or 4 things, and I completely forget about the rest. So, yeah. Any questions up until this point? Okay. So, because we're talking about requests and speed, we have to kind of understand the network. And essentially, we're going to talk a bit about the open system interconnection. Why? Why is this important? Because this is essentially the infrastructure that we're testing, right? So these are the layers that we'll be measuring performance over. So essentially, this is a compressed list of the OC layer. It has 7 layers. But in the application area, there's also a presentation and a session layer, which we essentially consider all of it in one application layer. Okay, so at the very base, we have physical cables. We have connections between machines. There's no magic there. But at the second level, we have the link layer. So here things start to form. At this layer, we have MAC addresses. Machines you start to have a problem between communication between 2 machines, right? Because you need an address where your package needs to go and how it needs to be received. So what is a package? A package is essentially a smaller piece of your data. So if you think you want to send like a picture over the wire, right? What's actually going to happen? The network layer will break down your HTTP request into packets, right? So essentially, it's going to reassemble all those packets on the other end. So in order to be able to assemble those packages, we have 2 main protocols that are defined. So you have the TCP and the UDP. Most of the stuff that we'll be talking about today is going to be on the transmission control protocol. So am I missing a slide? Oh, that was strange. Yeah, so what TCP ensures is essentially that your packages arrive at your destination. How is that happening? So we have to look a bit around the TCP and UDP requests. What's their their specifics? So you can see from the link layer we have an IP header, right? And over that we have the actual UDP payload, which is essentially in the IP request payload, right? So we have 2 layers of headers and a payload. The header is usually 8 bytes total, and essentially you have source, destination, length, and checksum. This is just to know how big your message is, where it needs to go, and where it came from. Now the TCP header looks a bit different. It can be around 20 bytes, but it can also have optional flags, so it can be a bit bigger. And what we're seeing here is essentially we're still building over the IP, under the link layer packets, but we have different data. So what we're really interested here is sequence number, acknowledgement number, and flags. So essentially, when TCP wants to do a connection, it's going to do essentially a three-way handshake, and it's going to set those header flags, right? So if you want to open a new connection between two machines, all your HTTP requests will function under the TCP. Essentially, it's going to say, can we talk? That's a synchronization call. The other machine will respond with a synchronization acknowledgement. Yes, we can talk. And then it's just an acknowledgement. OK. In the same way, the connection gets closed using the finish flag and acknowledgement. So that's the whole magic of how two machines in HTTP get connected. Yeah. Yeah.
Without the sequence number, how in UDP they are assembled by knowing this is the...
It doesn't guarantee. So UDP is used in protocols like voice over IP, right? So you can still make out a message if you're not losing too much of the whole package, right? So if I'm saying a sentence, if you lose one word, you can still make out the message. So UDP doesn't guarantee anything. If it's lost, right? TCP uses that acknowledgement system and sequence number, and keeps everything in order. Okay, so this is the point where we were getting. So if you're going to use tools like Wireshark or something that goes a bit deeper, you'll have three flavors of headers. That's just for you to know where they come from, right? And essentially where we are gonna be working on is in the yellow area. So we're working right in the HTTP area, right? And essentially you have a header, and this is mostly what we'll be working with. You'll have a request type, a destination, you'll have some content type is usually required, and it really depends on what header flags are set in. So, we kind of understand now how the underbelly works, but what's happening when we want two machines to communicate between them? Obviously, we're not using IPs in our day-to-day life when we're doing requests, right? So we're using something like www.google.com. So in that sense, we need to talk a bit about DNS. So domain name system is essentially a phone book for the internet. And it's essentially resolving strings like www.google.com into IP addresses, like you see there. Now, how does this work? We have this. So when you do a new request, where will your machine look first? Correct. Yes. So first, it's going to look if you have something cached on your machine, or it's going to look in the host file if you're pointing to some environment, right? If that doesn't go through, it's going to go to a top-level domain. So it's going to ask the root DNS servers, can you tell me who google.com is, right? So it's going to go to a top-level DNS server for the com. Then it's going to find Google alphabetically, and it's going to say, I don't know who www is, but I know who Google DNS is, right? So this is what you're going to get from the root DNS. It's going to point you to the Google DNS. And the Google DNS is essentially responsible for all the domains under the Google domain, right? So at this point, we're asking the Google DNS, okay, who's www, right? And Google will know, the Google DNS will know how to give us the www instead of the drive.google.com, right? So in a nutshell, this is how DNS works. Do you have any questions on this? All good? Good, good. Okay, so we kind of got through all the stuff we needed with the basic knowledge. But now we just need to talk about the components that we'll discuss in JMeter, right? So we won't be using too many of the elements, but what we're going to talk about is thread groups, variables, while controls, counters, HTTP requests, and a few extras on that, and view results tree for debugging. So how does all of this look like? So this is a thread group. The thread group element is essentially your orchestration element. So what you're seeing here, number of threads, is actually how many replicas of this thread needs to be done. So if you think about a thread is going to be executed top to bottom. So your request is going to go through the thread top to bottom. Your first request, second, third, right? If you're putting here 3, it's going to create 3 concurrent threads of that sort, right? If you're putting something like ramp up, if it's 1 second, it's going to start with 3 users, right? But if you want to do something like slowly increase, so if you're flooding a server, so let's say you want to hit a server with 100 users, right? Well, if you're hitting it with 100 concurrent users in 1 second, you might get DOD or something. You might get denial of service or not get the answer, or just it's going to behave strangely. What you need to do is to slowly increase to the number of users that you want to reach, right? So you would do something like 100 in 10 seconds. So when you're at second 5, it's going to be at about 50 users, 50 threads. One thing to note is you have to take into account how much it takes for your thread to actually execute, right? Because you might end up, when you're actually spinning up all your threads, some of them might have finished, right? So you might want to use something like the forever loop to maintain that number, But this is, again, this is orchestration. For this exercise, we're not going to edit this. This is just for you to know if you're doing performance, this is the place where you're mostly going to do your orchestration. Okay, variables. Variables can be declared either at the test plan level, or you have a special element like the thread or HTTP request, and you just declare it by name, so serve key and value, and when you reference it with $, curly brackets, and the same name. And that's your variable usage. Okay, while controllers. So while controller, it's a loop controller, obviously. You can look, don't get scared about this groovy script. It's specified in the reference, so it's no magic, right? So what you're seeing there is just saying use groovy to process this script, and it's saying do the while loop until the break while equals to true. And we're just saying here, we're initializing it in a preprocessor with false. So that loop will work until we change the value to it. Okay, counters. This is just a simple counter. You can specify the reference name. You can add the initial value and essentially the increment or the step. You can put 2 and it will jump 2 steps each time. Okay, there are some concepts in JMeter. There are pre and post processors, and the best way to kind of understand what a pre and post processor is to think about a flight, right? So in order to achieve flight mode, you need a liftoff and a landing procedure, right? So a liftoff would be your preprocessor, right? So think about it like this. If you have a request that needs to put a certain parameter in the URL, you might need to run a script before to concatenate, to form that URL. So that's your preprocessor. Your post-processor would be something like a regular expression extractor that always takes the content from the body and it does a regular expression or some processing. That can only happen after the flight happened, right? Because you need the response from the request. That's the post-processor. That's the whole magic behind it. This is how you have a regular expression, how it looks like. So essentially you're saying pick from the body of the request, and you're specifying create variable. This is just the name of the variable that we're specifying, sublink, and then we have the regular expression. So what it's saying here is wherever you find the href with quotes, right, get me everything that's between the quotes. That's the regular expression. Now the template is essentially you can you can do patterns. The tool is a bit more nice in terms that you could essentially put, let's say inside you put another one like this, dollar with slash slash, and that could essentially, you could have two variables that you extract, protocol and the URL, right? So there's a bit of configuration that you can do there also. Okay, and view results tree. Now the view results tree is our debug element. So it really depends where we put the view results tree. If we put it under the thread, it's going to record everything under the thread when it executes. If we put it under a request, it's going to report only that request when it executes. Or if we move it to the while, obviously, it's going to report only the while. So this is, you can kind of choose what kind of request you're identifying. Think of it like this. You might have a before where you're doing a login and you don't care to see that request ever. You're just interested after it logged in to have the debugger, to monitor everything. What is my purpose? So we're going to learn JMeter by crawling and pass butter. So what's a crawler? A crawler is also called a web spider, is essentially a script that essentially you give it a URL and it's going to go and find all the URLs in that website. It's going to crawl through all the links and try to, to identify everything. So these tools are usually used for indexing, but they're also used for security and performance. For us, it's just a way of learning JMeter and understanding how this works. So, you had the links before.
I tried accessing the Bitly link, but it came up for me, but I needed the login for GitHub Enterprise. Yeah, me too. I don't know how to go.
I'm gonna. Whoa. Fair. Can we do Slack or something so I can send you the... No, okay, it's fine. Yeah, so what we're going to do in this guide, essentially from this point, I want you guys to log in here. And essentially we're going to follow, there's a Medium article for how you can write a crawler, and we're going to do this together. And yeah, we'll see how it goes. Yes.
Yeah, so the Wi-Fi is going to be, you can connect to the Devops Playground Wi-Fi. You don't need a code for that.
Okay.
And the link is going to be probably easier if you go to www.devopsplayground.com/login.
Yes, I'm thinking of... Can I want to duplicate monitors. Mirror, yes. Good.